And again, moving on to number 6, please look at my explanation for number 5, or else this won't make sense. I mean, I'll try to make sense of it. But what is the work done on the crate by the total force? Okay, well, what was the total force that we figured out? It was 0. There's 0 net force. Why was there 0 net force? Why is there 0 net force acting on the crate? Because the crate ultimately is traveling at a constant speed. And if speed is constant, right, that means there's no change in velocity. If there's no change in velocity, that means acceleration is 0. And if acceleration is 0, remember F is equal to ma. If acceleration is equal to 0, then force comes out to be 0, total force. And again, that doesn't mean that there aren't forces acting on the crate. It just means when you net them all together, right, when you add them all together, the net force is 0. So again, how much work is being done by a total force? Well, what happens to this equation if F, right, the net force, is equal to 0? Net work is equal to net force multiplied by the displacement. There's no net force. Whoop. So there's no work being done by the total force. Is there work being done? Yeah, there's work being done, but when you net it all together, right, talking about the total force, no. Okay, so pay attention to those concepts. We still have to be aware of net force issues. We still have to be aware of trigonometry. We still have to be aware of our basic equations. Okay, but we have to apply our common sense concepts before we set up our equations, or we can fall into traps and get stuck and not even get close to the correct calculations.